In last lecture we have studied about the physical properties of the metals and non-metals, and now in this topic, in this lecture, we are going to study about the chemical properties of the metals and non-metals. So let me write over here chemical properties So here the total focus will be upon chemical properties of metals and non-metals. As you all can see, I have written something on the blackboard. This is known as reactivity series. Okay, this is known as reactivity series. What is the meaning of this? In the sense, like see, every metal and every non-metal has certain chemical characteristics. They react, they combine, but there is certain pattern, you know, like science work upon certain laws. It just cannot be like sometimes it is reacting, sometimes it is not reacting. So science totally work upon certain laws. Now which kind of law is this? We have arranged the elements in a decreasing order of the reactivity. Okay, that means when we talk about sodium and potassium, these are the metals which react most. Okay, most means even if you keep it potassium and sodium in the open air, it is going to catch fire. When we talk upon when we go upon the next one, when we talk about the calcium, the reactivity decreases. Again magnesium, again it will be showing lower reactivity. In this course, if we go down, if we reach towards the gold, you will find that gold, and we all know that gold is a metal which is the least reactive. It doesn't react, and that is the reason it is being used in making the jewelries. Even the temple of the Amritsar, Golden Temple, is the best example to talk about, because you might be knowing that this temple is a very old temple, but still there is like no reaction has taken place, just only because of the sense that it doesn't react. It is an inreactive, like it doesn't react, it's not a reactive metal. Okay. So at present we are going to study about the chemical properties. Now in the chemical properties, first of all I have drawn reactivity series. Here the metals are arranged in the decreasing pattern. Okay, it is arranged in a decreasing pattern of the reactivity, like potassium, sodium most reactive, and the gold which is the least reactive. Okay. Now when we talk about the chemical reactions, first of all means what we are going to talk about? We are going to talk about how these metals react with, sometimes with the oxygen, sometimes maybe with the hydrochloric acid, maybe sometimes with the water. Okay, so first of all we are going to talk about the reaction of the metals with the oxygen. Okay, so now we are going to talk about reaction with the oxygen. Now see, whenever we talk about oxygen, that something is reacting with oxygen, what does it mean? It means that a particular element is burning. Okay, burning requires what? Obviously burning requires oxygen. If something is combining with oxygen, means what? It's burning. Okay, so first of all we are going to study about the reaction of the metals with the oxygen. Okay. Now one more thing I would like to tell over here, that here we are not balancing the equation. Sometime I may write the balance equation, sometime the reaction may be the skeleton reaction. Fine. So first of all reaction with oxygen. Now in this whole course we have to note one point, like from the very beginning to the end we have to keep this reactivity series in our mind. We all should know and focus on this thing, that this are the most reactive element, and as we will go down the reactivity will decrease. Okay. So first of all reaction with oxygen. Okay. Now sodium reacts with oxygen. What is formed? Sodium oxide. Okay. Now again if I take the another equation, again I will just take few reactions and then I am going to explain you. 2Zn plus O2 give rise to 2ZnO. One more I will take 2Cu plus O2 give rise to 2CO. Now see, everywhere I have written 4 equations. Okay, now everywhere in each equation you will find metal is reacting with oxygen, and every time oxides are being formed. Okay, so these are known as metal oxides. Okay, please keep this thing in mind that whenever metal is reacting with oxygen, metal oxides are going to form. Okay, now it is forming, but we will see now how it is forming. Now when we talk about sodium, it is so reactive that even it can't be kept in the open air. I told you, even if it is kept in the open air, it is going to catch fire, and so it is kept in the kerosene. That means here it is reacting with the open air only. Okay. Now when we talk about magnesium, so just talk about magnesium, it has to be lesser than the sodium and potassium. Okay. So when we are talking about the magnesium, it has to, it won't be burning in a regular course. When we are keeping the magnesium open on the table, it is not going to burn. So what we have to do, we have to heat. Okay, we have to heat it. When we go to the next one, again Zn, it won't burn on simply heating. It has to be given strong heat. Okay, and copper, I will talk later, it won't burn only. Okay, first of all, again we are going to come here. When we talk about sodium, only in presence of the atmospheric air only it is going to catch fire. It is going to form metal oxide. Okay, so let me write here sodium, oxygen, okay, oxide, sodium oxide is being formed. So one thing is very clear with this, like whenever we are going to move down in a reactivity series, the reaction is going to become like the elements are going to be less reactive. Okay. Now when we talk about sodium and oxygen, sodium oxide are formed every time metal oxide is formed. Now I will tell you something about metal oxides. These metal oxides are basic in nature. These metal oxides are basic in nature. Means how we can prove that these are basic in nature? Okay, just not because I am saying it is basic in nature, what we will do, we will just try to prove it. Okay, now Na2O plus H2O give rise to 2NaOH. That means what is formed? Base is formed. Okay, now all the oxides are not at all, like we cannot dissolve all the oxides in the water, but at least few oxides are soluble in water. Those oxides which get dissolved in water are known as what? Alkalis. So alkali is going to be made over here. So what we will do, we will take that solution. Okay, in this solution, that means this one, where what we have done, we have taken metal oxide. In this, if we add water, a base is going to form. If I put in this solution, if I put red litmus paper, this red litmus paper will turn to blue. This red litmus paper will turn to blue, which automatically proves that this is base. That means it is basic in nature. So again, second thing is proof. What was the first thing? That as we go down in a reactivity series, the reactivity will decrease. This was the first thing which we have to keep it in mind. Second thing, when we are reacting, when some reaction is taking place with oxygen, that means the thing is burning. Again, so sodium or potassium, they burn in an open air, we have to keep it in the kerosene. Next, metal oxides are formed. When they are formed, when metal reacts with oxygen, metal oxides are formed. Now again, what was the next one? Metal oxides are always basic in nature. Okay. Then what I told, all the oxide do not get dissolved in water, but few get dissolved, and the one which get dissolved are known as alkali. See, it is not only with the sodium. If we talk about the magnesium, we all remember that in one of the class 6th, 7th we have done this experiment. If we take a magnesium ribbon and we allow it to, we burn it, it is going to burn with a bright fire, and in this course ash is going to be formed. Okay, what will be formed? Ash will be formed. Of what? Magnesium oxide, metal oxide ash will be formed. If we dissolve this ash into water, and then again if we take litmus paper, red litmus paper, it is going to be converted into blue. So here we have studied about the reaction with the oxygen. First of all, we have studied about the reaction with sodium. Sodium oxide is formed. Then magnesium, magnesium oxide is formed. Zinc, zinc oxide is formed. Okay. What is the difference? It catches fire in the air, normal way. Here we have to heat the ribbon. Here zinc, it has to be given a strong heat. That means it has to be heated strong heat has to be given. Now what happens in the case of the copper? In case of the copper oxide, it doesn't burn only. It doesn't burn, only a black color can be seen over here. Okay, a black color can be seen, or black color is formed, that means it doesn't react with it. Okay. Now after this we have also studied that when metal oxide get dissolved in water, base is formed. Now this base is basic in nature, and when we put litmus paper, red litmus paper to that, it get converted into blue color paper. Okay. This was the first reaction with oxygen. Now we are going to read reaction with water. Okay. Now when we talk about reaction of water, here also we will see that how the reactivity, okay, how the reactivity goes down along with this series only. Okay. Now again the same case is there with the, when we talk about sodium and potassium, they are so reactive that if they are kept in the open air, or even if the moisture is there in the air, what will happen? It is going to catch fire. Okay. So what has to be done? It has to be kept very properly so that the sodium and potassium do not catch the fire. Okay. Now reaction with water. Okay. Now here to begin with, again as usual we are going to talk about sodium, okay, plus water. Okay. Now here sodium is reacting with water. Sodium hydroxide is formed and hydrogen gas is liberated. Okay. Now again we will see in the same course, it will be going down. The reactivity series is going to go down. When sodium is allowed to react with water, sodium hydroxide means, just remember there metal oxide was formed. Now here what will be formed? Metal hydroxide. Let us see, I will tell you one thing. Whenever metals are reacting with cold water or water, okay, whenever anything, like whenever metals are reacting with water, what is going to form? Metal hydroxide. okay, hydroxides are going to form, okay. But when metals react with, okay, when, this is very important point, please note it down, that when metals are going to react with steam, so what is going to form? Metal oxides are going to form. These 2 points are very important when we talk about reaction of metals with water. What are the 2 points which is very important? That when metals react with water, metal hydroxide is formed, and when metals react with steam, metal oxides are formed, okay. So here when sodium is reacting with water, sodium hydroxide is formed. Why? Because it is reacting with water. What I said? Cold water, hot water, it should be water. It is reacting with water, so sodium hydroxide is formed. Same will be the case with 2K plus 2H2O give rise to 2KOH plus H2. Again potassium hydroxide is formed, okay. Now these 2 reactions are like, it takes very rapidly. Okay, now if we take one example over here, like suppose if we take one beaker, in this beaker we have kept water, okay. In this water we have to put a very small, a grain like piece, only this much piece of sodium. What will happen? We will find that like a fire will be seen, and after that if we put our hand into this water, you will find that this water is very hot. Why it is happening? Actually what is happening when sodium is reacting with water, hydrogen gas is coming out. This hydrogen gas comes out and it catches fire, it starts burning because the temperature becomes very high. So even it catches fire and sodium starts burning, okay. So this reaction can also be known as exothermic reaction, okay. It can also be known as exothermic reaction because here heat is getting evolved, and when heat comes out, we all know in this reaction even hydrogen gas is coming out. So hydrogen gas is it starts burning, it catches fire, and so what is happening? The water is becoming very hot. So it is known as exothermic reaction, okay. Now here these are very vigorous, very fast reaction, okay. So always as I am talking this thing, I am telling this thing from the very beginning of the this lecture, that why sodium and potassium has to be kept under kerosene. You please avoid this reaction. You should not do such kind of experiments in absence of the teacher. It is very important because any mishappening can take place. Now if I take 2 mg plus H2O, okay. So now suppose I am talking about, if I take here steam, so I know what is going to form, MgO plus H2, okay. So Mg plus H2O, so what is going to form, MgO plus 2H2, so I will write here 2. MgO means magnesium oxide is formed. Why? Because when metals react with steam, metal oxides are formed. So what will happen when magnesium is reacting with 2H2O, what will be formed? MgO plus H2 means again metal oxide is formed, okay. Now if I take magnesium and if I allow it to react with water, okay. If I allow it to react with water, water means what? Now hydroxide will be formed. So MgOH twice plus H2. I have not balanced the equation, I need to see MgOH twice, it is not here, 2 will come, okay, and here we can drop the 2, okay. So these are not the balanced equation, please pay attention. Now Mg, when it is allowed to react with steam, metal oxide means MgO will be formed, and when Mg is allowed to react with cold water, what will happen? Hydroxide will be formed. But you know, it is not going to react as vigorous, as fast as with steam. Like it is going to react more in a rapid way with steam rather than reacting with normal water or cold water. Now when we talk about, if I take second example, if I take suppose Zn plus H2O, so again what will be formed? It doesn't react with water, it has to be like passed, like steam has to be passed. So what will happen? Again ZnO plus H2 gas will be evolved. Okay, here also I can make this sign. Okay, so what we are studying now, this is a second point. First we have read about the reaction with oxygen, that means burning. Now when we are talking about reaction with water. Here first of all we are talking about sodium. Sodium has shown reaction with the water. What is formed? Hydroxides are formed. Okay, again two things we have discussed in this, that when metal reacts with water, metal hydroxides are formed, and when metal reacts with steam, metal oxides are formed. Okay, now we are going to move about the, now we'll just take one example of non-metal also. Okay, now if I take one example of non-metal, okay, so suppose I take sulfur. Okay, I am allowing sulfur to burn. Okay, that means what? Obviously oxygen. So what is going to form? Here I can write heat. Okay, and what will be formed? Obviously metal oxide or sulfur dioxide. Sulfur dioxide will be formed. I have taken one non-metal as sulfur. It is reacting with oxygen. It is like we are heating it. So what will happen? Sulfur dioxide will be formed. Okay. So this is what that means. When non-metals are allowed to react with oxygen, again oxides are formed. But now please remember, when we have read about the metal oxides, we know that metal oxides are what? Basic in nature. Now this one are what? These are acidic in nature. Okay, these are acidic in nature. So just to prove this, that we need to see like how these are showing acidic character. Now suppose I take sulfur in a vessel, in a jar. Okay, I have taken this thing, a spoon sort of thing. Here I have kept sulfur, and sulfur is burning. Okay, I have introduced this thing into the vessel and I have covered this. This is totally covered. So obviously when sulfur will burn, it is going to create or release certain amount of fume. These fumes are collected over here. Okay, this fume is getting collected over here. It is being closed. The lid is closed. Now what will happen? Total fume will be collected over here. Okay, now if I add water into this, okay, if I add water into this, means what will happen? I am talking about SO2. SO2 is reacting with water. Then what will be formed? H2SO3 will be formed, which is known as sulfurous acid. Okay, this is known as sulfurous acid. Now in this sulfurous acid, if I am going to put blue litmus paper, okay, it is going to turn into red. The blue litmus paper will get converted into red. So again this proved that non-metals oxides are acidic in nature. What I have done? Non-metal, I have taken one non-metal, sulfur. It is reacting with oxygen, and so oxide is being formed. Now this oxide is allowed to react with water, so sulfurous acid is formed. Again the name only indicates that it is what is forming? Acid is being formed. And to talk about the experiment, I have taken a jar, I have allowed a sulfur to burn into this. The fumes are being created, and here if I add some little amount of water, so what will happen now? Sulfurous acid is formed. Now here if I put blue litmus paper, it is going to get converted into red litmus paper. This means again it proves that non-metals oxides are acidic in nature. Okay, so this was about, like I have taken one non-metal. If I talk about one more non-metal, but before that I need to clean the board.